So there's another way we can create functions. We saw half here. Another way we can do it is with an expression. So we can say half colon equal, and then we take our function, we remove the name, and we can do it that way. So just like JavaScript has two ways to create functions, Go has two ways to create functions. We can create them like this, func main, or we can create them like this, func, and assign it to the variable. Okay? So now I
miss JavaScript.
What?
I miss JavaScript. I guess getting comfortable with it after 6 weeks.
So we can call the function inside of main, but now we're not going to be able to call half anywhere else. We can only use it inside of main, because the scope of half is only to here. So the reason that's interesting is that allows us to do closure. So let's go look at that.
Allows us to do what?
Closure.
Oh, closure.
So it is possible to create functions inside of functions. So here's an example. And I will call this closure dash example. Oh, oops. I meant to create a folder. And then go in there. Okay. So here we've created a function just like our add, just like our half. We have an add now, and it just adds two numbers. So this is like doing plus, really simple. And then we can call it, right? So if we look at our example, we can do this. So let's say we made an increment function. Okay, so I'll try to explain this. Instead of passing in x, we're referencing x here, okay? So this x refers to this x, okay? So I'm incrementing, and then I return it. So each time this is run, x gets bigger. So the first time it's run, it becomes 1, and then I return 1. So we should expect this to return 1 and then 2, okay?
It keeps x global after the first time.
X is within main. That other function is also within main, so it gets x.
Yeah, because of the scope. So with 1, 2 is what we expected to see. And so this x here is referring to this one. And so here's the tricky bit. Now I can make a function that returns a function. Okay? And I can make it like this. We can copy this and put it over here. And I can return this function. Okay?
Can you explain the signature? Just read it.
Yeah. So this is a function f, and maybe I'll just call it I don't know, increasing numbers. Okay. And it returns a function that returns an int. Okay. So I'm creating a function and returning it. And this x is from here, and so now every single time I call this function, x is going to be incremented. So we call our increasing numbers, and maybe I'll add generator just to make it clear. And we'll say numbers is that. And then every time we call numbers, it should increment that x. Right? Oh, sorry, I forgot to remove it. So the same result, okay? So I've returned a function that increments this x. Now, when I'm in here, I don't have access to that x, right? And so the function here and the things it binds inside here, that's the closure. That's a closure, okay? And so this function has within it access to this x. So, everybody following that? That can be a little confusing. JavaScript uses closure a lot, okay? So you guys saw it probably with events, when you like bind to events and stuff. And you can access variables that are not inside that function. Yeah?
Are you declaring that function at the beginning, so it's a preliminary declaration, and you can use it anywhere, so its scope
Yes, this function is, and then this function can only be used in main. This is a function, numbers. If that's,
Yeah, 'cause on 14, you're executing increasing numbers generator, that function. When that function executes, it returns on line 7 another function. So numbers is now sort of like this other function. And so on line 16 and 17, you say numbers execute this function with the curly brace or the parentheses. And you're executing basically lines 7 through 9, but they still have access to the variable on 6.
yeah. And so this printf%t will tell you the type of something, which is sometimes handy. So this is a func of int. Let's just say int1. Oh, it's because I didn't put a new one.
What is it int 1?
It was because I didn't put a new one.
It's because what?
I didn't put a new line on the printf, so then it printed the 1 from numbers from this call immediately. So yeah.
Percent T returns the type.
Yeah, so this is handy sometimes if you're not sure, like, I don't know what this is, you can use the %t to tell you what type it is.
So numbers, the function numbers returning what?
Ints. It returns an int.
What was the, it was the number, how did it know it was 1?
It's returning the value of x.
X plus 1.
And every time it gets called, it increases the value of x. Okay? So I think there's another example in here that we can look at. This make even generator. So let's look at that. So make even generator, it starts out at 0, and then it increases by 2 each time. So what this does is it gives you the even numbers. Every time you invoke it, it gives you the next even number. Okay? Following what I'm trying to do here? So this is 0, and then 2, and then 4. And each time you call it, it's going to be a bigger number. So the interesting thing about this is that we could create the even numbers, like this. And so on. And we could do that in a loop. But the problem with this is we have created a very large block of data. And it turns out, if we don't need the previous even numbers, we can just generate them on the fly, and we can do it with this, okay? So this is how we can generate even numbers using closure.
All right, so
Closure. Right.
line 6, UN is that the one that's going to be 32 or 64 depending upon your computer?
Yeah, the unit is unsigned, so it just can't be negative, that's all.
But it'll be like int 64 on most machines.
Yeah,
Is that correct?
a unit 64.
Unsigned. And then you've got 8, 9, and 10 return I, and I plus equals 2. So it starts out at 0. Is that
Yeah, it said here.
UN, you're casting the 0 to UN there.
Yeah, so you can do it that way, or you can say,
Var UN equals 0.
you don't have to give it equals 0.
It automatically goes to 0. And then every time it says 0, and then it returns 0, then it adds 2 to it. So it's returning even number each time. And then just the closure keeps basically that variable alive and keeps I alive.
Yeah. So the modifying is kind of unusual. You don't see that a ton. The referencing you do see a lot of. But it's way more common in JavaScript than it is in Go, because Go doesn't have the event. The way the events work is it doesn't work that way. So you don't have to pass in callback functions to everything in Go. Okay. So you don't tend to have to use closure that much, but you can. That's the point, is that it supports closure. Some languages don't support closure, so.
Is I could just be I equals 0, right? Like for U ain't 0?
Yeah, if we wanted to return ints instead of uints, we could do that, right? We could change all these to ints. And then get rid of this. That would work too. We could also get rid of this and just say return I, and then not name of this guy. That works too. You can't do I plus equal to though, as an expression here. You can't do this. It's bad.
And you call this a callback. I don't know, like that's a phrase that I'm still trying to nail down my understanding of. basically, every time you call next even, it's calling back the next even generator. Is that what a callback is?
This is not a callback.
Oh, I just heard you say callback.
Callbacks are use closure. In JavaScript, you use callbacks a lot, and that's where you run into closure a lot.
That would be more like an event.
The callback is the name inside of here, basically. So I'll show you a callback. What's a good example? Call visit, and you give it a slice of integers, and it takes in a callback of func in. And the idea here is that we're just going to visit every number. And call the callback for that number. Okay? So you would pass it in a function, and it's going to invoke it, call it for every number. So let's run that. And the way we do that is we say visit, give it some numbers, and then we say okay, and it will invoke this function that we passed in. It will invoke that for 1, 2, 3, 4, okay? Because we loop over it and call the callback. That's where the callback is. So the callback is the callback inside of here, but out here it's just a function. I'm just saying that often this function here will reference variables. So it'll say, okay? So I'm using x. Here's a closure. I'm using x because it's a variable outside of the function. And then n is coming from up here. Okay. To give you an example of why you might want to do that, instead of visit, you might do filter. And this might return a slice of ints. And then you'd say something like, instead of a func, you'd make it return a bool, and then you'd say if callback the number, then you would append it. And then you'd return x's. And with this, you could filter a list. So I can say filter ints 1, 2, 3, 4, and then the func will be n greater than 1. Oops, crap. And then if we print that, the idea here is that should print 2, 3, 4. So what we've done is we've passed in a callback which defines how to filter our list. And it just calls the callback. If the callback is true, then it appends it, otherwise it doesn't. And so that's how you can implement the filter. This is not a common way of doing Go. You can certainly do it this way. A lot of people do for some things. Very common in JavaScript. And so in real JavaScript code, this is just every other line is going to look something like this. But I just wanted to show you can do it in Go. So if we run that example, 2, 3, 4. So the closure we can say, max is 1, and then we can replace the 1 here with max. That's how we can do it. Okay. Everybody following this? Is that super confusing?
No, I'm very impressed. That was like awesome live coding. Because I don't know, for my skill set level, that's pretty complex.
Yeah.
I'm just starting to grasp that, like, okay, I can wrap my head around that if I sat with it for 5 minutes.
Yeah. So if you've done functional programming languages like Lisp or Haskell, this is this way of dealing with functions is super common. And so it's like an approach to development. And so you get used to passing functions around. Go allows you to do that, but it's not the most common way of writing code. The more normal way you write something like this is just a for loop. And that's perfectly fine. For loops are easier to understand. Okay, so the other big topic is recursion. So a function can call itself. So in this example factorial, we take in a number. If it's 0, then we just return 1. Otherwise, we return x times, and we call ourselves. We call the same function again. Okay. calling factorial of x minus 1. And this is how you compute a factorial. Okay. So it's a little confusing because it's like, how does this ever finish, right? Like, where's the loop? You don't see a loop in here. And the way it works is you have to sort of just follow through the code, right? So say I pass in the number, let's make sure this all works the way we expect it to. We'll call it recursion-example and make a new main file. Package main, and then function main. And we'll give it 10. Incidentally, don't give this function big numbers. There. So that's the factorial of 10. Well, 10 back. That's what we've computed. So the way this works is you start and you have to like walk it through in your head what it's doing, right? And so we say the factorial of 10, it's not 0, so we don't do that. We go to here. So we return 10 times the factorial of 9. Then we go back up here and say it's not 10, or it's 9 is not 0. So we do 9 times, and we keep doing that. Eventually we get to 0, and then we return 1. So you end up with in this example, you end up with 10 times 9 times 8 times 7 times 6, and so on, 2 times 1.
Times 1, it does times 1 twice.
Yeah, that's fine. Yeah, so you have to think of it like, it's not just like laying it out like this. It's actually computing, if you give it the factorial of 1, it's going to return 1 times 1, right? And then it's going to take that value and compute 2 times 1 times 1. And then it's going to compute 3 times, and you can quickly see how this grows out of hand, right? And that's sort of the recursion, it's starting way down here and building up, right? And so this is finally there's a base case that happens where this happens, okay? That keeps it from going on forever. And so once this happens, then it sort of unwinds all the way back down, getting the values. So, everybody following what we're trying to do here? So recursion is a way of solving problems, and you can use loops and you can use recursion, and often you can solve the exact same problem with recursion. But people tend to have a hard time thinking about recursion. And I think what throws them off is this whole base versus the call. Because you look at it, you're like, how does this ever finish? What is it even doing, right? And so you have to sort of think it through to figure it out. But you can solve all kinds of problems using recursion. So
Recursion is not very performant, I've heard. It's like it's an interesting computer science.
it depends on the problem. But yeah, the downside of recursion is, well, can anybody explain the downside? Somebody want to give it a shot?
Log X. X is actually more difficult.
No. The issue is that every time you call a function, that's going to push more data on the stack. And so this gets called, a lot of times. So
Compared to other things like a PCU as a new, going all the way to a function is hard because it's recording where it currently is. It has to grab more space in the stack for any variable in the function, and then it has to jump your entire code base over to where it's executing up to the function. And then when it's done with the function, it has to reverse all that. So compared to something simple like addition, it's a lot of work.
yes, so yeah, it's just that the stack, having all the stack gets really expensive. So it can be slower, but it depends on how many times it's recursing. It also depends on the kind of data you're working with. If you're working with a tree, like a DOM tree in HTML, recursion is great. It totally fits the problem. Because when you're like visiting all the nodes in a tree, that's a classic recursive problem. You want to write a function like this, where it's going to be like, if it's text node, do something. If it's any other type of node, go visit all its children and call it again, okay? And that is a great way to build this kind of function. So I'm just saying Go allows you to use recursion. You can call a function from itself, okay? I don't know how often you're going to do it, but you can certainly do it. Like factorial is a great example of when you might. I don't know why you'd calculate that, but you could. Okay, so that's closure and recursion. The last small thing here is the defer and panic. I'm not going to spend a lot on panic, but defer is interesting. It allows you to make a function call get moved to the end of the function. So, if I want to compute this, I can defer it. So let's make that do something. Okay. So normally, if I did this without defer, it would print a factorial 10, and then it would print hello world. But because I use defer, it's going to make this go to the end of the function. So defer's pretty straightforward in how it works. So you see what I'm saying? Hello world happened, and then the factorial call happened, even though they're in the reverse order in the source code. And that's because I use defer. Defer moves the function call to the end of the function. Defer is super useful because often we do things that we have to remember to unwind later. So if I open a file, I have to remember to close it. And so it's nice to be able to open a file and then defer the close. Now I'm going to go use the file to do stuff, and then the close will happen last. Okay? It puts the close right next to the close. So that's what's nice about using defer. But pretty straightforward. Just think of it as moving this call down here. Okay? I'm not going to talk much about recover because I'm not sure we're going to need it. Just there is a way to take these panics and recover from them, but it is kind of clumsy to use. So I don't want to spend time on that. I just want you to know that panics are recoverable. If you panic, you can recover from it. It's kind of like a catch, like when you catch an exception. It's like that. But I've honestly never had to use it, so it's not that common. Okay, so we have an hour left, and I have a lot of example problems for functions. Because I thought that at this point, you pretty much have the keys to make a lot of interesting programs now, because you can build functions and stuff. And so, I mean, we've done a lot of coding today, and I think that is super helpful. It's like you can convince yourself, oh, I learned this, and then you try to use it, and you're like, oh, maybe I didn't learn this, right? Like, you found it very confusing. So that's why I had a lot of example programs.